right. This is actually being recorded on homecoming week, and today's Spirit Day was college day or career day. So I've got my college. I went to Iowa State University. Anyway, so we're our last lesson of chapter 4. We're moving right along through these chapters, and today's lesson is triangles and coordinate proof. So looking at triangles in the coordinate plane. And actually, we're going to practice, this first thing's not a triangle, but it says place a 3x5 rectangle in the coordinate plane. So don't just go put it anywhere you want. Think about it. We might need to use the coordinates to find a distance or a midpoint or something like that. So it would be helpful if we put this rectangle in a certain place. So I want you to think about, there's two main places that would be good for us. So maybe try to pause the video and think about, I guess I could give you a hint if you're not sure where to start it. Probably would be good to put one of the vertices right here at 0, 0. Because if we're using the distance formula or the midpoint formula, having some zeros will make that easier. Okay, so if you paused and you finished that rectangle up, so the main ways would be either to draw it vertically or horizontally. So I don't really have a preference. I'll draw it vertically. So 1, 2, 3, 4, 5, and then 3, and then we have that. So if you have a ruler or a straight edge, your old school ID, something to draw a straight line, it's usually nice if we can make it look better, make it look good. Why not? Alright, so now we want to label all these coordinates, so you can do that in practice. So x comes first, y comes second, so that's 3, 0. This is 0, 5, and this is going to be 3, 5. Alright, and so I'm just going to shade that a little bit. You can color it, whatever you want. Alright, so that has advantages to where we put it to calculate certain things because there's a lot of zeros there. So that'll make it easier. Alright, excuse me. Okay, so now we're going to do a right triangle. And the right triangle has legs of 6 and 8. So again, pretty similar situation here. There's definitely some better places to put it. So, and it says find the length of the hypotenuse. So we're going to actually have to do something with this. Maybe we should add that to that next year. You don't have to write this down, actually. All right, so you can pause this and try to put that triangle on there somewhere if you want to. But so obviously one of the vertices, we want one of the vertices to be on the origin again because that's going to be 0, 0. So pretty much you would think that anytime you had a choice, you probably would put something at the origin to get those 2 zeros for calculations for formulas. Now, you may be thinking of putting that triangle up here, but it would be better, 1, 2, 3, 4, 5, 6, 7, 8, it would be better to keep the other point on the y-axis, 1 on the x, because that, again, will give us a 0. Instead of coming up here now, 1, 2, 3, 4, 5, 6, that would have 6, 8, comma 6. But if I just go up here, 1, 2, 3, 4, 5, 6, now I have another 0. So that's 0, 6. So you can see that I'm trying to maximize the number of zeros. The more zeros we have on a graph, the easier some calculations will be. Okay, so now label the vertices. So we did that, and then find the hypotenuse. So this is a right triangle, and to find that, we know that this is 6, and we know that this is 8, And so hopefully you've seen that before. That's the Pythagorean theorem. A squared plus b squared equals c squared. We also could use the distance formula actually. So let's, since we've done that for sure in our class, let's use the distance formula. So the distance formula says x minus x, so that's going to be 8 minus 0 squared plus 0 minus 6 squared. So that's going to be 64 and 36. And that's 100, and that's 10. Okay?